Hello, everyone, and welcome to this new episode of Learn Stress Free. I'm your host, Jeff Rodrigue. My goal with this podcast is to make scientific knowledge accessible to the public in a way that's fun and easy to understand for everyone, even your 5-year-old cousin. All thanks to my expert guests who conduct research in academia. In today's episode, we're going to talk about climate change, a topic that affects everyone. Our guest will explain why it's important to care about climate change. Drawing on his expertise in extensive scientific research, he'll debunk some common misconceptions and misinformation surrounding climate change and answer questions such as, what do we mean by climate disruption? What do we mean when we talk about tipping points in climate change? How does the scientific community measure historical CO2 levels over thousands of years? What are the current and future impacts of climate change in our society? But before we dive in, I just want to mention, I want to make science accessible to as many people as possible, which means I do this podcast in French and in English. Most of my guests will have English as a second or sometimes as a third language. Even for me, English is my second language. So just keep that in mind if we're looking for our words or our pronunciation is suboptimal. In this episode, thanks to science, you'll find answers to these questions and more. Without further ado, let's learn stress-free with Philippe Gachon from the University of Quebec in Montreal. So, hi, Philippe.
Hi, Jeff.
Thank you for being here. Thank you for joining us on today's episode. So, as is my habit, I like my guests to introduce themselves because no one's better at knowing you than yourself. So, Philippe, tell our audience, who are you? What brought you here?
Thank you, Jeff, for the invitation. My name is Philippe Gachon. I'm a professor of hydroclimatology at University of Quebec in Montreal. I have some background for sure in climatology, in meteorology. I'm working also on regional climate modeling, on different kind of atmospheric hazard, including also flood, heat wave, forest fire, different kind of storm related to wind extreme or other kind of magical hazard could have some strong influence on the ground. It could be on a natural but also a human system.
You're talking about heat wave. We're early July, and so heat wave is affecting actually a lot of us. So our listeners, or probably have, if you're listening to the episode later, you probably have bad memories from this time period. Okay, so thank you very much. So to begin, I think it's important to clarify to our audience why we're talking about climate change and global warming, because I often hear people say, well, it's cold, so the planet isn't warming up, or that there's no point in talking about climate change because the climate has always changed anyways. What can you tell us about that?
Okay, regular question, especially come from certain people who like to have some deny. The first important thing, climate has changed over a different period of time. Natural viability of climate means also change during the time. We have also, for example, in the last 2.5 million of years, fluctuation within the climate system with glaciation and interglaciation. In other words, warm condition compared to cold condition. We are in an interglacial period. And this variability is mainly due to three main factors. The amount of solar radiation comes from the fact that we have a variation in the eccentricity of the orbital cycle from the sun, from the Earth compared to the sun. And also, certain time there is a larger extent, in other words, less vicinity from the Earth compared to the sun. When we have also this higher land, we have also less amount of solar radiation. This could influence the amount of energy, who also has a strong effect on the genetic budget for the Earth system. We have also a variability, the Earth within the orbit around the sun. There is a modification in the axis. We could have a higher slope compared to the Earth is more or close to
Sun?
yeah, we have a slope within the orbit in which we modify the amount of solar radiation, especially for polar region. Okay,
Okay.
the inclination of the Earth within the orbit. Okay, the second parameter, and the last one, it's precipitations of equinox. In other words, the distance between the Earth and the Sun during the equinox, and this could change also the amount of solar radiation. In other words, this is natural, but this induces some long-term modification of the climate, but it's directly natural factors.
And you mentioned energy balance. Is
Yeah,
that
it's
the
in
expression? What does that mean, energy balance?
the energy balance. To have the climate that we have, we need to have heat, a solar energy. If we do not have this, the climate will be completely different. In other words, the energy that we obtain, that we have also within the climate system, comes from the three kind of parameters that I discussed: habitual eccentricity of the orbit, the inclination of the within the axis, and the precession of the equinox, the distance that we have during the equinox. This amount of energy is important to maintain a certain amount of each within the climate, to have also, for example, close to before industrial period, we have climate, the mean value of the temperature around the Earth, it's around 15 degrees C. Okay, and this amount of this temperature feature is strongly directly related to the energy that we receive from the sun. Now it's the natural factors. Okay.
If I may, so basically what I'm understanding, just make sure I understand right. So the energy balance, so you just talk about the evolution for like over 2 million years of natural
Yeah,
phenomenal.
there is a fluctuation within the 2.5 million of years with four glaciation. When we receive the minimum of energy, this means a glaciation. The Earth start to enter to a cold phase. Okay?
The ice age, like the movies. Ice pretty
Yes,
much
ice age,
everywhere. And okay.
glaciation, yes. When we have more energy, we go progressively to interglacial, it's a warming condition. Okay?
Like we are now.
And yes, we have now. Now, till 20,000 years ago, we have a glaciation. Okay? The amount of ice in Montreal was more than 2,000 meters. Okay?
2,000 meter
2,000
in
meters.
Montreal.
Montreal.
It's
Yeah.
for those listening right now, it's 40 degrees Celsius in Montreal. It's felt as 40 degrees Celsius. So there's definitely
Yeah.
not a single inch of ice. I don't know in
Yeah.
Fahrenheit how much it is. I'll do the
No.
conversion maybe later, but it's
During the cold phase, we have more ice, and there is some ice in Montreal. Okay?
a long time ago. That was a long time ago.
60,000 years from now. Okay? During the glaciation, we reach the maximum Holocene. It was the interglacial period in which we start to develop agriculture, Neolithic period, and the temperature was close to 1.5 warmer compared to certain other interglacial condition. Okay, it's natural system. 6,000 years ago, interglacial. 20,000 years ago, glaciation ice stage. Okay, now the other important factor to keep certain amount of energy within the system come from the greenhouse gas. Greenhouse gas, the important greenhouse gas within the climate system are CO2, methane, water vapor, and the oxide nitreux, in other words, also another important gas. We have also seen during the time with ice core that we keep with the ice when there is some ice. Greenland, Antarctica, we have some huge amount of ice. During the period in which, for example, precipitation, soil precipitation, it's not only frozen water vapor. This induce also keep certain amount of air. And the air, as during the period in which we have also, at the time in which precipitation, solid precipitation go to the ground, the atmospheric CO2 within the air parcel represent the CO2 concentration during the period in which we have the solid precipitation.
You touch an interesting point there because it's a question I have later on, because sometimes we hear people say, oh, but how could scientists know how much CO2 level there was like 1,000 years or 2,000 years ago? And what you're saying is the precipitations that happened at that time froze and is now stuck in the ice that we have in Antarctica or Greenland. And then the scientific community can basically go, it's basically almost like time travel by going into those ice peaks or ice sheets that still carry some air from when the precipitation happened?
Yeah. During the time in which the precipitation got to the ground, there is an accumulation, for example, of solid, especially during the ice period. Could be also during, for Greenland or Antarctica, also during the warm period. And can put some ice core just to keep certain amount of ice and air, and we date the amount of CO2, and we could have an age in which we have a CO2 concentration at the time that the precipitation has go to the ground.
That's thanks to carbon 14, is that it?
Yeah, exactly. There is carbon 14. There is all the kind of methodology to have some age. Yeah. In other words, with this ice core and other also sediment that we have, for example, within the oceanic core, we could have also, for example, diatomae, certain species are directly in relationship to salinity and temperature of the water. Okay, during their life. We can do exactly the same thing compared to ice core. I have a core within the sediment in the ground of the oceanic area. And we could have also a date in which we have this species at that time, and this species is directly related to the current condition when they live. In other words, with these two, ice core and also oceanic sediment, we can date exactly not only the period in which we have cold and warm condition, but also CO2 concentration. Okay? And we have seen during the last 2.5 million of years, during the cold period, we have less amount of CO2 concentration within the atmosphere. And during the warm condition, we have higher concentration of CO2 in the atmosphere. And we have also, we know this, it's a thermodynamic also and relative processes, physical knowledge. We know that the CO2 concentration and greenhouse gas has a direct effect to keep more or to let more amount of heat within the climate system when there is high concentration. And I will explain a little bit. Okay. In other
Just so
words,
you go,
to return, we have cold period with lower concentration of CO2, warm period, higher concentration of CO2 in the atmosphere.
it goes back to, well, first of all, I want to say that's why I love science, because we can, through scientific method. So if people wonder what the scientific method is, I invite you to go back to episode 1. Episode 1 is dedicated to explaining what is the scientific method. And through scientific method, you manage to be able to know basically historically how things evolved as far as CO2 and other gases and the species and all of that through the science. So this is one of the reasons why I love science. And second of all, you said gas effect. Is that a green gas?
Greenhouse gas.
Thank you. The greenhouse gas has an impact on the level of CO2, and you just explained that the level of CO2 explain basically high level of CO2 means warm weather, warm climate, and low level means colder climate, and that those greenhouse gases actually increase the level of CO2, which means increases the temperature. So is that where maybe human impact comes in?
Let me finalize my explanation, just to explain a little bit about what is greenhouse gas. Okay?
The question.
Now, we have within the atmosphere a certain amount of gas, water vapor, CO2, methane, all the kind of gas. We have also ozone. The amount of radiation, solar radiation, will go from the top to the atmosphere till the surface, the amount of radiation, 50%, around 50% are diffuse or redirect to the space, and around 54 or 52% reach the ground to warm the ground. Okay? Now, the Earth surface, we discussed about the fact that around 15 degrees C, emit certain amount of radiation in infrared. Okay? And the greenhouse gas keep certain amount of this infrared radiation from the Earth's surface. As soon as we have more CO2 concentration, greenhouse gas, we keep more energy within the climate system because we keep more infrared radiation from the Earth. And there is a direct link between the amount of CO2 and the fact that we keep more heat within the climate system. Okay? And it's an important aspect, and the scientific knowledge talk about the fact that there is a fluctuation, low value of CO2, low temperature, high value of CO2, high temperature. And we have also more and more knowledge from the fact that human activity, since the beginning of the industrial period, we use what? We use fossil fuel. And this has a certain amount of not only methane, but also CO2 within, and we burn this, and we increase the amount of CO2 within the atmosphere. For example, only to talk about CO2. And we can see clearly, since the beginning of measure of the CO2 within the concentration, historical, talk about past period, glaciation, but historical monitoring of CO2, especially in Hawaii, in the Pacific area. It's Hawaii Observatory of CO2. The killing curve, we can see clearly since around 50, there is a strong increase of CO2 concentration directly related to the human activity, the fact that we use fossil fuel for the energy consumption. Okay?
Just to repeat for our audience, so it's been scientifically proven by observation and measures scientifically that since you said the 50s, more so the industrial
50s,
revolution, basically.
yeah, we start this, but we have also CO2 concentration before, because I talk about this ice sediment, but also ice also within the sediment within the oceanic. But yeah, direct measurement of CO2, it's around after the Second War. Okay?
That's when it starts really picking up and going out.
Exactly.
Because from what I understand, because you're talking about the energy, and from what I understand, when you mentioned earlier at the beginning, is there seems to be, from what I understand, there seems to be like a sweet spot that we need temperature-wise, to have the climate that we have and the living conditions that we have, and this balance seems to be pretty
Yeah.
fragile. And then because we emit more CO2, you just said, so the radiation comes from the sun. Some of it is filtered by the gas in the atmosphere. It reaches the ground to
Yes.
warm us up, to basically allow our climate. Most of it is bounced back, so it doesn't stay in the system. But now the amount of CO2 kind of causes an umbrella or a dome, if I may, as a
Yeah,
metaphor,
like
that
an
keeps
umbrella.
that
Yeah.
energy here instead of allowing it to go back in
Yeah.
space.
Yeah, exactly. And we can see, for example, since the beginning of mid 90s, okay, the amount of CO2 from the ice core, but also sediment within the lake, within the oceanic area, a CO2 concentration within the atmospheric condition was around 250 ppm.
Okay, so in the 90s, it was 250
Yeah,
particle per
two,
million.
270. No, nowhere, 270. Okay,
Okay.
ppm. Now, after more than 150 years of activity, human activity, in which we use more and more fossil fuel, the concentration of CO2 within the atmosphere is around 424 ppm.
Okay, so just so I recap, because I think I misunderstood. So it's not the 1990s, it's the 1900s. Is that it?
Yeah,
Okay.
mid 90s,
Okay,
the
so like
concentration went
1950s.
270. Okay,
Okay.
and right now we are close to 424. ppm is the concentration in terms of per volume of air.
No scientist, but that seems like an insane increase in a very short
Exactly,
period of time.
and exactly, and it's an important point. We have never seen, for more than 10 million of years, like a rate of increase of CO2 within the climate system. Never, except during the period in which we have an asteroid and a clash of the climate system, because there is a strong increase of CO2, but also other kind of volcanism could have naturally modified the CO2 concentration. But in the last 10 million, I repeat, in the last more than 10 million of years, we have never seen an increase of more than close to 1.8 multiply of CO2 concentration during this kind of short-term period.
The only variable is us, basically, is our activity.
It's us. Cannot be. There is some natural also viability due during the winter. We do not have also photosynthesis aspect. There is a seasonal value, but never natural cannot be responsible for this kind of CO2 increase in terms of concentration within the atmosphere. Now, last point. We know that there is also continue to have natural factor responsible for small piece of change in terms of temperature. But progressively, especially the IPCC, International Panel of Climate Change, who combine all research in a climate aspect, there is not only a consensus, but all analysis, measurement, studies show that especially during the last 5, 6 decades, the fact that we have an increase in terms of warming, more warmer temperature, an increase in terms of temperature, cannot be due to natural factors. The 90% of this increase, or more than this, come from the human activity, the CO2 concentration induced by the use of fossil fuel for the energy consumption.
There's a metaphor I like to say, because when people tell me, oh, but the climate has always changed, so it's no big deal, my thought is like almost, okay, but humans have always died. Like, we live and we die, but we have a life expectancy. Let's just say for the exercise, let's say we have a life expectancy of 100 years, let's say. So yes, people always died, but let's say you die at 100 years. But now if we take the climate change over the course of the history of the data that we have that goes to millions of years, and we watch on that timeline how much the last 50 to 60 years had a huge increase, I feel like if it's a human life, it's almost as if, yes, people always died, but now no one makes it past 1 year old. I'm pretty sure people would be like, oh, there's a big problem. How come no human being lives longer than a year? No one would say, oh, but it's okay because humans will always die. People will be freaking out. But now when we put this on a climate change perspective, people say, oh, but climate has always changed. Yeah, but what used to take thousands of years to happen is not happening in the lifespan of a human, because our lifespan is not, like, in the big scheme of all things, our lifespan is nothing, right?
Yeah.
But now
Yeah.
in our own lifespan, we see those things, this big spike. So I'm like, you cannot ignore the fact that, yeah, climate has always changed, but it's going so much faster than it used to.
Exactly. And the rate of warming has increased recently. For example, recent publication, especially publication in February, March this year, has shown that in the last or since the ratification of the Paris Protocol 2015 till 2025, the rate of warming has increased. In other words, we have more and more increase of temperature because we cannot stabilize the CO2 concentration such as we are supposed to do within the Paris Protocol. Just to return about a little bit about this. The rate of CO2 increase, we discussed about the fact that it's unusual in the last 10 million of years. And it cannot be due to natural factors. Okay, perfect. The rate of warming has increased. And this rate of warming, the fact that we have a strong increase, especially in the last 5-6 decades, it's mainly due to the CO2 concentration come from human activity. The other important point, in the Holocene period, 6,000 years from now, we reach also a warming period in which the climate system was also warm. But recently, we progressively go up to this higher rate of warming that we have seen in 6,000 years ago.
Our human activity since industrial revolution warmed the planet more. So there's two things. So it warms faster, as you just said, but now what you're saying now is that we warmed more than what the planet naturally, if I may, warms itself through the cycle.
Yeah, except during the dinosaur period.
But it got hit by an asteroid, so that seems like an outlier. That's not something,
Yeah.
because I think if an asteroid that size hits us, it killed a dinosaur. Like, I wouldn't bet on us surviving that.
No,
But we don't have control over the asteroids.
exactly.
Yeah, maybe if you watch a movie Armageddon, but that's scientific.
Yeah.
Like, that's sci-fi. But we have control over our own activities.
Exactly.
What we do on a daily, and what we ask from our leaders, and what we ask from politicians, and how also we consume. For sure, I was joking with my dad yesterday, like, we ordered food and there was the paper straws. And I look at him like, oh, I need to use a paper straw because I really need to offset the useless private jet trip that some billionaire took, you know? So my paper straw really matters. But you mentioned we warm up faster. And it's actually a question I had for you. Is my childhood friend is a marine biologist. And he explained to me that global warming creates what he called a positive feedback loop regarding the rate at which the planet is warming. So what does it mean, the positive feedback in climate change? Because from what I understand, it's called positive feedback, but it doesn't sound positive for us. As a species, it doesn't sound really positive.
Yeah, it's a good point. Just to explain what is negative feedback and positive feedback. For example, we have more heat within the climate system. We talk about this. It's the greenhouse gas effect. And this more warmer condition mean that we defrost, we thaw the sea ice, for example. We thaw the ice because more warm or more heat within the climate system, we have less amount of ice. It's true for Antarctica. It's true for Greenland. The rate of decrease in terms of the amount of ice within the Greenland area, it's huge, especially during the last 5, 6 decades in which we have a more and more warm condition. Less ice means we change. I explained a little bit about the albedo. When you have a surface, white surface, only 50% of the amount of heat go to the surface or go down to increase the temperature. In other words, 85% is redirected to the space for white surface. When we do not have a white surface, we have a ground surface or a black surface. It's a reverse. We have 90% of the heat who reach the surface is kept for the surface and it warms the surface. Only 10% is redirected by the surface to the space. In other words, with less amount of ice, we decrease the amount of area in which we have white surface instead of brown or other kind of surface. And this albedo effect increase the warming in the surface. In other words, as a positive feedback, induce more warmer factors compared to the fact that we have also more greenhouse, gas and also warmer condition.
It's basically the problem feeds itself.
Yeah, exactly. The positive feedback means we amplify the warming only due to the modification, for example, for the algae.
So the warming itself makes the warming faster.
Exactly. A negative feedback, reverse, could be a decrease of the amount of warming. In other words, reduce the amount of warming if it's a negative feedback. But in terms of oceanic area and also sea ice that we have, especially over polar and subpolar basin, the decrease of sea ice has more and more positive feedback to warm the air and also oceanic area. It's the reason why we have an amplification of warming condition in the polar, Arctic and subarctic region. This area, including in the north of Canada, which we have more and more, we have also inland sea, but also sea in which we have sea ice during the winter. The polar amplification means that we have for certain around in the globe, especially in the north, 3 to 4 times the rate of warming that we have at global scale.
To 4 times. And global scale is an issue. And you say 3 to 4
Yeah.
times faster than what is already an issue? That sounds like a much bigger issue.
Here, we amplify the warming. We talk about this in amplification of the Arctic warming. It's due to the positive feedback, such as explained, and also due to the fact that Arctic area also, there is some sea ice, especially during the summer, and less amount of sea ice during the summer, more sea ice during the winter, and less amount of sea ice during the summer. But because we reduce the amount of sea ice both during winter but also during summer, the oceanic area, Arctic Ocean, keep more and more energy. And we can see clearly not only the Arctic amplification for the atmosphere, but also Arctic region, Arctic oceanic area, keep more and more heat. In other words, the surface, but also go down to certain amount of for certain area, more than 2 2,000 meters of oceanic depth are warmer when we analyze during the time the warming condition.
I don't remember exactly all the things that he said because we had a boys' night that was all over the place. But I remember one thing that he said, and I don't remember the exact reason why he said that, but that sentence really stuck with me as a marine biologist. He said, as a species, as humans, one of the things we absolutely do not want to do is warm up the oceans. He said, we have to make sure that we don't do that. And from what you're telling us is that's actually the thing that we're doing. Like the big warning label with the flashing red lights and the sirens that said, do not do this, do not do this. Humans are like, you know what? I want to do it even more.
Yeah. Yeah. It's an important point. And your colleagues, marine biologists, is right. But I also will explain a little bit. You know that more than 71% of the Earth's surface is water, oceanic area. Okay? In other words, this water surface play a key role in the climate system to keep certain amount of water, but also to have the source of humidity. It's mainly due to the presence of water in the oceanic area. In other words, the strong majority of the Earth's surface, it's water. If we warm more and more water, this heat, the memory of the heat is kept within the oceanic area. And recently, last week, the observatory Copernicus system in Europe, they measure also they combine different kind of data sets, and we have seen last week that the warming in the oceanic area has reached a level that we have never seen during the historical period. Again, since the beginning of metrical, but also oceanographic measurement. In other words, the rate of warming has increased, especially in the atmosphere. The amount of heat within the oceanic area has increased. And the problem that we have currently, and I will just explain a little bit of the link between more warmer conditions in the oceanic area. What does it mean
That's a
for
good question.
species? Yeah. What does it mean for marine species, for acidity, for all the kind of things? We can see that the rate of warming of oceanic area has increased, not only at the surface, but till 2,000 meters within the oceanic water mass. It's huge. It's huge. In other words, to release this amount of more heat within the oceanic area, it will take a huge amount of time just to return to the equilibrium state.
Because nature strives for balance.
Yeah, we induce more and more imbalance within the climate system with the energetic budget, with the continuous increase of CO2 concentration. Now, to go to what does it mean, more warming condition for oceanic marine species? More warmer condition means a migration of certain species doesn't want to have warmer condition. For example, salmon, they need cold water. In other words, certain area, too warm condition for certain species such as salmon. Other kind of thing, we modify the biodiversity because more warmer conditions, certain species, there is a decrease. Certain has increased because they have or more adapt to warmer condition. But the other important thing, we reduce also, for example, the coral reef. There is a whiting situation for coral reef, to decrease the amount of coral reef within the globe, because coral reef, to continue to live, they need to have certain amount of stable condition for salinity, but also for temperature. Outside certain threshold of temperature, there is a modification of coral reefs and they start to death. And the coral reef for certain area or for the strong majority of area, they produce or they can keep certain amount of biodiversity because they are there. In other words, when they disappear, the species who strongly depend on the presence of coral reef disappear. It's another kind of aspect. Other kind of aspect, the decrease of sea ice has a direct effect on certain species who depend on the presence of sea ice. We talk about not only on polar bear, but we talk about, you just remember the
Seals.
seals?
Yeah, I'll have to censor that word, sadly, for the algorithm. But the word, because the word seal in French is pronounced the word we have to censor in English.
Yeah. In other words, certain species depend on the presence of sea ice, and we know that certain algae depend on the presence of sea ice. In other words, the modification of temperature strongly modify the biodiversity, and we can see the decrease of biodiversity in marine area, a decrease of the amount of coral reef, and the species will depend on the presence of this. The decrease of sea ice has also a direct effect on the presence of certain species who strongly depend on the presence of sea ice. And the last point, less amount of warmer condition means less oxygen within the water column. Less oxygen means more epoxy, or condition in which we have less amount of oxygen means also a decrease in terms of biodiversity. And the last point, as soon and the oceanic area is also a sink of CO2, absorb CO2 for photosynthesis production.
The same CO2 that we want to keep as low as possible.
Yeah. Oceanic area are responsible to keep or to decrease the amount of CO2 in natural and within the natural factors. But more and more CO2 in the atmosphere keep needs also for oceanic area to keep more and more CO2, and this absorption of CO2 within the water column decrease the pH concentration. In other words, oceanic induced to be less than more and more acid.
That sounds
And
bad.
this exactly because this means a decrease for certain species who strongly depend on the less acid, more basic condition, especially coquillage,
Seashells.
seashell, to have the thé calcaire, etc., etc. In other words,
Because it's a word that you're using, and I thought this week of how can I make people care about that word? Because you said biodiversity. So biodiversity is basically the diversity across the biosphere, like the different species that needs, because balance, nature strives for balance, and nature is in balance until we make it unbalanced. And we hear a lot that part of the that we lost a big chunk of biodiversity in the last decades, and people don't really seem to care. And sometimes people are, oh, I don't eat that, I don't care. And I'm like, okay, but
no,
when
no,
your food runs out of food, how long before you run out of food also? So that's one. And second of all, biodiversity, I think the way I'm now going to explain it for people is like without making it too complicated and too scientifically is why should I care about biodiversity? It's because we need it to stay alive. So when you hear we lost 30 or 40% of biodiversity, that means you lost a part of what you need to stay alive. So even if you don't know what the word means, you should still care. And this episode, because what you say is actually is very, very interesting, and I find it so well explained. But for our audience, the goal of this episode is not to make you go in panic mode and start Armageddon or start the purge. That's not the purpose. The title of the episode is to understand climate change, because I think as a society, it's hard to, and that's the purpose of the podcast as a whole, also to explain things that people don't necessarily understand, because climate change impacts us all. All
yeah,
of us are concerned by climate change. And sadly, I think too many people don't really understand it. And we hear a lot of words from the scientific community, and it's hard to put the pieces together and understand what it really is. And so that's the purpose of the episode. It's not to make you start the purge, is to realize that we have an impact as humans, as has been explained so well by Philippe. This is what is happening at different level, the sea level, the land level, how warming feeds itself. Like the more warming, the warmer it gets. We have record temperature, we have record pace of warming. And I think that's why it's important. One of the sub-objectives of this episode is kind to raise the alarm and raise the flags for people to say, we need to pay attention to that as a society. I think we need biodiversity more than we need the stock prices to go up. I think.
Absolutely. We need more biodiversity. We depend on more biodiversity compared to fossil fuel to live. A decrease of biodiversity means we decrease the amount of capacity to heat, to take some good water or good quality of water, and also to have environment, a well health environment in which we need to consider that it's a crucial aspect for us. A small example, like an abeille,
The bees.
uh,
The bees.
the bees.
Yeah, the bees.
The bees, there is a decrease in terms of bees due to the too much pesticide within the distant. The bees has a strong effect to be able to have flower, to have also a possibility to have biodiversity. Certain plants strongly depend on the presence of bees. If we do not have the bees, we do not have for sure not only miel,
Yeah, honey. No more honey. That would be bad. I put some on my
less
toast this morning. Honey's so good.
no more honey, but also certain species, certain fruit are directly related to the presence of bees. It's a small example. It's a case for marine area, for just to remember about the fact that a strong majority of people, especially poor people, depend on the presence of marine species to eat. They don't eat meals like us with a huge amount of meat that strongly depend on the marine biodiversity and the presence of certain species in the oceanic area, but also in the river system. In other words, this has a direct effect of the amount of or the good health in biodiversity means more capacity for us to maintain our life, to continue to stay there. And the last point, we are a natural species. We are come from the biodiversity aspect. And we need to remember that without this, we cannot be there. As a
Yeah, I think that's the thing. People think, oh, the planet, the planet will die. No, the planet is fine. The planet doesn't need us. The planet is much older than us and will survive us probably by a few billion years. It's ourselves that are a hindrance to ourselves. It kind of brings me to the next question, and I think they're kind of all intertwined. So basically, I'll ask a question, and maybe because there seems to be like a good flow to answer that. So first off, and then I'll answer. So first off, you said during our pre-interview meeting, you talk about upheavals disruption, climate disruption, and I don't think I ever heard the term disruptions to talk about climate change. So that's one. Then we have, what does tipping points mean when we talk about climate change? And is it related to the famous 1.5 degrees Celsius target we've been hearing for so long from governments' action plan? And also the other one is, how does it affect people? Because I feel I'm not that old. Okay, I'm just 41. I'm not that old, and I feel the difference from when I was a kid. Less birds, less. I remember when you drove at night, you have to clean your windshield so often because so many mosquitoes will just smash on your windshield. Now it's not even an issue anymore. No more mosquitoes, which sounds bad. We're in a heat wave right now, especially if you're near Europe. Canada is getting hit, but Europe is much, much worse right now. And I remember as a kid, like very, very intense temperature where you don't even want to go outside. It was like 2, 3 days in the summer, and that was it. And now it's weeks, and I'm just 41. And that's why I find it, I don't want to start a generational war. That's really, really not the intent there. But I know human psychology, I know denial is so strong. And it really fiberglass me when even older people than me, so people who are in the 60s or in their 70s, don't believe in climate change. I'm like, you saw even more changes and disruptions than I saw at 41, and you still don't believe in it. It's your own eyes, it's your own experience. So basically, what are the climate disruptions, upheavals? I'm guessing it's going to feed the question, how is it going to impact us, and how is it already impacting us also? Because we talk about global warming and all that, and climate change, but it's global, and it's not going to affect, I guess, everyone the same way, because the earth is it's a pretty big place. So what is upheaval or disruption in climate change? What are about the tipping points and the 1.5 degree? And I'm guessing it's going to feed into how it affects us now and what can we expect maybe in the short, medium, long term, as far as, because the human is, we are a sadly selfish species, if I may say that, right? Unless it affects me personally, many people won't really care. So how maybe to help the people who might not care about climate change to start caring more? How is it impacting them today? How would it impact them? Because I feel, I might be wrong, but I feel that some people think that climate change is going to be all or nothing. You go at bed tonight, everything is fine. You wake up tomorrow morning, everything's on fire. It's not a switch that you just, it's literally the frog in the boiling water. And in that scenario, we are the frogs.
Yeah. Okay, start with disruption. First, we talk about the fact that the rate of warming has increased. It's more and more a concern for us, but also the rate of warming has especially increased in the last 5 decades, and more increase in terms of rate of warming the last decades. We can see with this destruction are strong modification. It's not only a change, a linear change. It's more and more an exponential change. And with this exponential change, especially for temperature, and I will discuss this before to talk about tipping point, we can see clearly that there is more, this rate of warming induce more and more extreme heat wave, duration, intensity, occurrence of heat wave. For example, in Europe, they have 2 strong heat waves at the beginning of not summer, in May. We can see clearly that there is also another one in June. It was also the case in Montreal in 2022, if I remember well. We reached a value of 360 degrees C in Montreal in May. Normally, we can see this kind of warming condition in August, not in May. In other words, the occurrence of heat wave start to be more and more early, a longer duration, and a more intense heat wave. Remember that in June 2021, we reached 49 degrees C in British Columbia. It was in Lighton. 50 degree north, close to 50 degrees C.
Yeah, it's
Normally,
not a destination where you go on the beach.
exactly. Normally, we can see this kind of warming condition in the middle of the Sahara, in tropical area, not in 50 degree north.
In Canada, for those of you,
Yeah,
so
it
it's
was
BC's
in
in
Canada.
Canada, where
In
there's
other words,
snow and ice during the summer, and
yeah,
not the summer, the winter. There's no
winter.
ice during summer. Not
In
now,
other
not for now.
words, we have more and more this kind of event, heat waves, strong amount of precipitation, and I will explain a little bit about the link between high value of precipitation and the link with temperature. But let's just summarize this kind of destruction. We have stronger event of precipitation, such as we have yesterday in Montreal, such as we have also for the Canada Fest in the 1st of July, and the fact that Ottawa has also a huge amount of rainfall, maybe a record for this, especially during a short-term period with strong wind, and this has made some disruption for Fest of Canada. Continue about the fact that we can see certain tornadoes occurrence has been modified, especially in North America. We have also more storm. In other words, more extreme related to the rate of warming. And I will explain right now the link between temperature and precipitation, because the strong majority of extreme are directly related to the change in the precipitation regime. Okay? Including heat wave. Heat wave means we have more humidity in the air, especially for us in North America, and the temperature is more higher, not only during the day, but also during the night. Well, there is a link between temperature and precipitation. There is a physics law. The name is Clausius-Clapeyron law. We can see that there is, according to the temperature value of the atmosphere, for example, high value of temperature means higher capacity for atmosphere to keep a certain amount of water vapor. And the link is exponential. In other words, at low temperature, we have low value of the water vapor in the atmosphere. More and more warm condition means more and more capacity to keep the water vapor in the atmosphere. Exponential link. In other words, because we warm the atmosphere due to the increase of CO2, due to the increase of greenhouse gas, the atmosphere can keep more and more humidity. This can induce more higher value of precipitation, more rainfall, because we keep more water vapor. And we have seen this. During the time in which we have a warming trend, we can see certain areas in which we have more extreme of precipitation.
Is it linked? Because I know, for example, in Quebec, the government had to update the map of the flood, the zones that are at risk of floods. Because recently we've had floods where we never had floods. And is it the case? Because, correct me if I'm wrong, from our understanding, if the air is colder, it can hold less water, less vapor. So I guess it releases more frequently. So I guess it's maybe more. So our infrastructure and the soil itself is able to absorb more, which makes it that, it rains, it's okay, I do whatever I have to do. Versus now, if it's warmer and the atmosphere can hold more water, but I guess eventually then when it releases it just releases just a little bit. It releases it all at once, and that's why we have flash floods or more than we used to.
Let me explain. Flood is one thing, but flood can be due to different kind of things. It's not only such as we have in Quebec, a river flood. We could have, such as we have recently, not only a flood related to the amount of too much water within the river, but urban flood means too much water in the ground and not capacity to have a design storm, especially for sewer flow. There is more sewer flow come from the fact that we have too much water at the same time during the short period of time. And it's not due to the river flow. Okay? It's due to the too much water on the ground in which we have no capacity to have infiltration of within the ground, because we have impermeabilization of surface condition with more and more urban condition. It's one aspect. Continue to about the link between precipitation, water vapor, and temperature. The energy that a storm needs to develop is directly related to the amount of water. Because we have another aspect. a latent heat release. When we have more and more water within the atmosphere, the latent heat release can also induce more and more vertical motion, induce more convection, increase the amount of possibility to have precipitation, okay, especially in summer. But also the latent heat release due to the process come from the water vapor to the liquid form induce some more heat in the atmosphere. Positive feedback. This induce more intense storm events, not only related to potential increase of precipitation, but also more storm, more intense storm means also higher speed of wind, downdraft, certain downbursts that we have seen yesterday with a certain amount of electricity power was shut down because the trees has go to the electricity line, etc., etc., to the strong wind gusts that we have yesterday from the thunderstorm, but also in Ottawa area. In other words, disruption means more extreme event due to the high rate of warming and high value of temperature in the atmosphere, means also, because the oceanic area has warmed, more evaporation. We do not only increase the amount of water in the atmosphere, but we increase also the evaporation because warmer condition in the atmospheric water mass means that there is less amount of energy to pass from liquid to water vapor to evaporate the water mass compared to cold condition. This takes more energy to evaporate. In other words, we increase the humidity in the atmosphere. We increase the evaporation, especially over the oceanic area, but also lake, such as the Great Lakes that we have here in North America. We increase the recycle or the cycle of water within the climate system. First part, disruption. Now I'll talk about the tipping point. Tipping point, one or two examples, and we don't want to go there, to go there, yeah, for certain...
Just PC. Basically, what you're saying is we do not want to reach that tipping point.
Yeah, as a species, for sure. An example of this, because we currently have this in Canada, we have also this in the last 4 years. More warmer condition means more capacity to have also more water vapor, more intense precipitation, but also we increase the volatility of the water cycle. For example, more warmer condition, we evaporate a lot, but when there is no precipitation, the drought condition could increase. In other words, we increase the excess and deficit of water.
So we feed both ends of the spectrum. And I have a guess you're going to talk about agriculture.
Yeah, and I will explain a little bit about tipping point and point also about the agriculture. Tipping point, though, and we have seen this, and it's true in Canada for certain areas over the globe, but also in Canada. We have seen that during the time with a more warmer condition, we increase the volatility, period of persistence of time in which we have drought condition versus excess of precipitation. Okay? When we have more warmer condition and less amount of water, what does it mean in terms of tipping point? Wildland fire. Fire area has increased. In the north, currently, there is warmer condition, especially the end of May, certain amount of days without precipitation, thunderstorm, lightning,
Fire.
And we have never seen recently, the last three years was completely unusual. The record was 2023, in which we have also a huge amount of burn area across Canada, and it was a record. But 2024, 2025, and we will see for this year, we increase the amount of extent for burn area for certain part of the.
So basically, how much is burned?
In 2023, we talk about 14.5 million of hectare, equivalent of the 2 times the size of Portugal.
Of wildfire basically burning everything down, and we say that we see more and more. So the area of what nature burns, because of the mechanism that you explain, it's warmer, it's more hot, but it's drier because it doesn't rain. So nature burns wider areas.
Exactly. And it's a tipping point. Why? It's because for certain area, too much regular burning condition means the forest cannot be renewed, because short-term cycle of burning condition for certain species, they do not have enough time not only to recover natural, but also to have their own capacity to produce
basically to regrow and to create
exactly. Especially for our species in Quebec, because normally the needs, for example, for epicea, like 50, 60 years of time to grow, to
go back to maturity,
to produce their grain. And when there is a fire, they can also naturally regenerate. Okay? In other words, certain area, there is no capacity for natural regeneration. We lost certain area of forest condition.
So the tipping points is basically, from what I understand, are points of no return.
Exactly. It's we can have a certain equilibrium. We can reach, or we can keep within the system, but a tipping point means we pass for another state, and we cannot recover the previous state.
And so the 1.5 degrees Celsius, sorry for the Fahrenheit, I'm not sure, but the 1.5 degrees Celsius, it seems, from what I understand, it's like our first big tipping point. Because also I think it feeds into what you said earlier. The more it warms, the faster it warms. So I'm guessing if we reach that famous 1.5 degree we've been hearing about for so long, then reaching 2 and 2.5 will be much faster. Is that right?
Exactly. Yeah, exactly. It's the reason why the Paris Agreement has put the threshold of 1.5 not to be above, to prevent this kind of tipping point, but also to increase the amount of risk for extreme event occurrence.
And those points of no return, where, for example, the forest is not able to regenerate.
Exactly. Another 2 short examples before to go to the impact of a tipping point. Permafrost, sea ice. Permafrost is the amount of ice or the water within the soil in the north is frozen because it's too cold to be like a liquid in liquid phase. Okay? If we have more and more heat within the soil, but the water will not be frozen, will be liquid. In other words, this will modify the water cycle within the soil, but also we know that within the system, in the permafrost area, we have a methane. Methane is a greenhouse gas.
That we don't want.
Yeah, and this is normally keeping the soil due to the frozen condition. As soon as we have a defrost condition, we release certain amount of natural greenhouse gas. This will amplify the warming. It's another tipping point.
Okay, so it's not necessarily, because for sure the ice melting will be an issue, but it's also releasing even more gas, which is going to feed to even more warming and faster warming.
It's the reason why we need to prevent any reaching this kind of tipping points. The same thing for sea ice. Disappearance of sea ice during the summer in the Arctic region means no kind of seal, no polar bear for certain areas, and other species who strongly depend on the presence of sea ice. The same thing from Greenland ice sheet. The Earth will completely disappear because we do not have enough cold condition during the winter to keep solid precipitation, snow, on the ground compared to the amount of water that we release during the sowing.
But just before we dive in for the impact on our daily lives and what's to expect, I read that the 1.5 degree has been reached. Like the 1.5 degree that government said we can't reach. Did we reach it? Or maybe it's the way it's measured or presented for clickbait, maybe?
We reached this 2024 was the warmest year ever recorded in the last 150 years.
2024?
2024.
Okay.
2023 was the second warmest.
Oh, there's a trend.
2025, the third. In other words, the last 3 years we reached the warmest years.
So our last 3 years, because we're in 2026, I don't know when you're listening this, maybe you found the podcast somewhere in the pond on another planet or something, but we're in 2026, and you said, so basically 2024 was the warmest, 2023 was the second, 2025 was the third. So the last 3 years, so people who still don't believe in global warming, the last 3 years around the globe, so maybe in your area it's colder, because as we said, global warming drives the extremes, both.
Yeah.
But the last 3 years have been the third warmest on record.
On record.
And we don't know 2026 yet because we're halfway, but it's not looking good so far.
We'll see. Now to return about your question, in 2024, we reached the value above 1.5 compared to industrial reference period. Okay,
that's important. Yeah, the reference point is important. So it's 1.5 degree globally.
Globally,
we want to keep that above pre-industrial.
In 1850, 1900 reference period.
Okay.
In other words, the last 5 decades of the 19th century as a reference period, we have reached above 1.70, 52 or 53 higher than compared to this period, but only for 1 year. When we talk about 1.5, this means for 3 decades. In other words, but with the rate of warming that we currently have, we'll reach the 1.5 more rapidly than we have anticipated a few years ago.
Okay? So it's warming even faster than the scientific community initially anticipated. But I think, sorry, kind of diverging, but I think also there was hope that the political leaders will actually do something, which doesn't seem to be done much. So
in Europe, in China, in Japan, not in North America, such as we have also a problem with the return to the past.
Yeah, that's a whole other issue. I have a podcast next week. My record is on politics, so we're gonna have this.
Continue about the now. We talk about the hazard. We talk about disruption. We talk about tipping point. I have also forgotten to mention about the increase of water level, and this tipping point. Certain area will be under, not over, underwater, because more and more ice is frozen. In other words, more and more water go to the oceanic area and also increase the water level. The other factors responsible for the increase of the water level, that it's due to the temperature of the oceanic area. Because as soon as we increase not only the atmosphere, but the water, these occupy an increase in terms of volume.
Oh.
Okay? And the two effects related to the increase of water level is temperature increase of the oceanic area, water mass, but also more water comes from the greenhouse ice sheet and also Antarctica responsible for more water go to the oceanic area. Now, return to the impact. At a tipping point, water level means certain area will disappear as an area in which we can live. Okay, especially for Asiatic area, we talk about 800,000 million of people. Okay,
100 million people?
no,
800,000 million?
yeah,
Close to a billion.
yeah, close to 1 billion. No, sorry, 800 million of people are directly affected by the increase of water level because they live close to the water, to the sea. Okay. Now to return to the impact. I'll go to the impact. For sure, the high intensity event has an effect on the flow, not only for river, but also within the urban area. This induces strong damage, wildfire, effect on the forestry ecosystem, security for people who live there. We also have certain events who will appear in the future that we have never seen. An example of this, especially recently, we can see some thunderstorm more and more frequent in the north that we have never seen in the past. Why? It's because it was colder in the past compared to right now. Because to induce some thunderstorm, everybody knows we need to have a huge amount of heat on the ground, more convection, more capacity to evaporate, induce some thunderstorms, such as we see recently, regularly in the last June months, more strong amount of thunderstorm event.
Which used to not be able to happen in the north because it was cold
Exactly.
enough to prevent that. But now the warming make it so that those events that hadn't happened before are now starting to happen.
Yeah. We have seen certain thunderstorm in the north that we have never seen in the past. Okay. Tornadoes has also increased in terms of maybe not only occurrence, but potentially intensity, because it's more warm in the surface. When there is a cold condition within the atmosphere and a warm condition in the ground, this induces more probability to have this kind of event, strong event, tornadoes. Other kind of impact, for sure, the two most important impact in terms of economic costs come from the storm. Higher event or more intense event means more economic cost, and this has increased in the last decades. And also water, flood and drought condition, excess and deficit of precipitation.
Which both affects agriculture that we need.
Exactly. Meal security, health security, to have enough food to produce with the pluvial agriculture.
I heard, because still agriculture, but I think it was a scientist, but I'm not sure, but I heard that they say basically the climate change is going to be first and foremost food insecurity crisis. So before we get flooded or burned by wildfire, or before the food insecurity because of the worsening condition that makes agriculture so much harder, because either it's over flooded or it's too drought, so it doesn't grow. So basically both sides of the spectrum that are bad. So I heard that the food insecurity crisis is going to hit us before the reality of the climate itself. Is that what we're on track for?
Yeah, right, because we can see more and more migration due to the food security, especially from Africa, for certain area in tropical area in which they strongly depend on the amount of precipitation, because there is no regulation of water to keep the amount of water for agriculture. And it's a key issue. Food security means more and more migrant with other kind of, for sure, difficulty related to civil war.
And we saw people go nuts for toilet paper at the beginning of COVID. So when it comes to food, I'm a bit more worried because you mentioned costs. I know we heard that because fossil. I don't want to start, the tinfoil hat, whatever, fossil fuel lobby or whatever. But I mean, when they say, shifting to sustainable energy would be too costly, and I'm thinking, okay, but what's the cost of not doing it? Because I feel
No,
like the cost, not only financial cost, but the human cost, although
exactly.
is so
There
much
is
bigger than the bottom line of whatever
exactly.
Excel spreadsheet you count your finances in.
You are right, but also it's wrong to talk about the clean energy are more costly, effective. Wrong. It's less cost to use electricity power for transport compared to fossil fuel, especially during the current period in which we have also a war between Iran and
So it would
also
be cheaper and better for the environment and for our odds of survival
exactly.
as a species, but we're still not doing it because stock market needs to go up, I guess. I don't know.
Exactly. We can see an example of this. Chinese, the amount of production of battery, electricity power, solar panel that they have developed in the last 2 decades, this has induced a lower price to produce this kind of clean energy compared to fossil fuel. In other words, there is no reason to use right now clean energy because the higher potential consumption comes from China, but also production of clean energy has directly an effect on the cost of energy. It's the reason why we need to increase the amount of capacity to deal with this clean energy compared to use of fossil fuel. It's a wrong manner to not only to develop, but if we continue to use the fossil fuel, especially in North America will be the area in which we decrease the capacity to not only to adapt, but continue to produce the problem.
Because I know for Canada so I don't know if it's North America as a whole or just Canada, but I read that Canada is the region on Earth that warms the fastest.
One of the fastest, yeah.
Which is as Canadian, well, as an Earthling and as a Canadian citizen, I don't like that.
Yeah,
I really don't like that.
yeah.
So we
The polar amplification that we talked about before has a strong effect on the more warmer condition, especially here in Canada.
Well, all this to say to our audience, like I said, it's not about scaring people, but I think as human that are part of society, as voters, as taxpayers, I think that being more informed and helps us to make better decisions, but also helps us to ask better from our leaders also.
Yeah,
And to follow
exactly.
the purpose of the podcast is also to follow the science, what the science says, not what the politicians say or the lobby is saying, because as we talk about in episode 1, science doesn't care about feelings. Science is about facts. You like the facts or not, science doesn't care. The facts are the facts. And one of the reasons why I want university professors to be guests on my podcast is because they don't have a skin in the game. They don't have a skin in the game. They're here to tell you the data set, like the scientific community has been studying this subject for X amount of time. This is what the data says.
Yeah.
So you cannot like it, but it is what the data is, what it is. We need as a society to, to work together to tackle this
Exactly.
change and to ask for better for us, for our kids, for future generation. And
Yeah.
so, yeah. So before we go, is there, because my podcast aims to address disinformation, so is there anything, false beliefs or things that you hear about climate change that we might not have covered?
A last maybe point before we go to the disinformation. Yeah, we know the problem. We need to be part of the solution.
We know the
Okay.
solutions. That's the frustrating part. It's not like we don't
Exactly.
know, like we have a problem and we don't know what to do. We know as a society, the scientific community knows the solution to our collective problem.
Reduce the amount of CO2 concentration means we need to reduce also the use of fossil fuel, use clean energy, take care about the ecosystem, preserve the biodiversity, the water, the clean water, the high quality of water is strongly important. Ecosystem in a good health is also an important aspect. In other words, we know the solution. We need to apply and also to work together. Okay. And the climate change, could be an issue. It's a big concern for the planet, but also for us, for the biodiversity, for all species across the globe. But also, it could be also the manner to reinvent the capacity to work together for the right thing, for the right purpose, for our new generation. And also, we are responsible part of the problem. We need also to consider to be more solidaire,
More
with
solidarity among
more
more solidarity with
solidarity,
our peers.
with the kids and the new generation. Last point, and go to the
Disinformation.
disinformation.
Yeah. So what's quick editorial comment? I feel I said to some friend like COVID really, like, I feel as a species, COVID was a practice test for climate change, which is the real test. It's like, okay, can you set aside your difference to tackle a common enemy and maybe, step onto your own comfort for a little while for the greater good? And then, so I felt like COVID was like, okay, guys, here's a curveball, learn how to work together, and then you'll tackle climate change. And we dropped the ball so hard. So now disinformation. So is there, because maybe we covered most of what you hear already, because I feel on my side, I hope the audience feels the same, but I really feel like it was explained incredibly well, the why and the what and the mechanism that creates climate change. But is there any false belief that you think needs to be tackled before we go for our closing comments?
No, well, we need to also to think to reduce our home consumption. Do not use, for example, our cell phone for any reason. Reduce also because these take some energy. A strong majority just to between us, Amazon, Google, the strong majority of
Data centers that are being built is a whole other issue
exactly
also.
take more and more water and more energy. And does it mean it's not clean energy? A strong majority of the time. In other words, we need to consider to reduce the consumption for also and change our manner to deal with this kind of issue and problem. Now to go to the disinformation. We learn about this. We learn about the fact that science was also a manner to not only to tackle or to isolate, to develop the knowledge, to develop some probing data to see the problem. We know exactly right now where the problem is, what could be the solution. So reason why it's really important to prevent any disinformation or malinformation or
Misinformation, disinformation, misinformation.
misinformation. Sorry. Why? It's because, for sure, it's a normal. When we have a problem to deal with, the first reflex is to deny. No, it's too big. There is somebody who has developed something wrong to keep me in a bad situation. It's the first reflex. After this first reflex, the second step will be, okay, it's a real problem. But the real problem comes from what? In other words, we need to have probing data, transfer of knowledge, to understand the problem, to find the solution. Disinformation will induce a dark denial, or reflex on
Denial.
continuity, prevent action, because the problem not come from us, not come from the society, not come from individual behavior. And inaction or inaction will also induce some no solidarity that I talk about our kids, our future. And the last aspect will also certain time induce some bad behavior. And you not want to go too much in a detail about this. But in other words, this information, it's not based on scientific knowledge. It's based on the deny information circulation and the fact that we ignore the problem. Misinformation. We could have the right information, but misinterpret the information or, for example, the impact of climate change. For sure, for both disinformation and misinformation, we need to continue to work on what? Education, sensibilization, continue to transfer knowledge, not only for young kids within the school or at university, but within the society. To explain the problem, but also to explain that there is some solution, to take action. It's really important because during the historical period, we have seen the importance of education, of transfer the knowledge within the society to prevent war, prevent conflict, prevent misinterpretation about the priority, and also to give us together a mission, not only to survive, but to continue to develop in a sustainable way. Education, sensibilization, it's a key issue to prevent too much effect on the climate change, but also to prevent the problem with misinformation and disinformation. Because
Yeah, well, it kind of brings me to my last question, because my last question is drawing inspiration from the conclusion of a scientific article, because you talk about the importance of educating and, making sure that the information is understood properly. Is basically what can we expect from you, Philippe, as a researcher, but also in your field? What's like in the research, like a scientific paper says, okay, what's the future avenues of research? So what's the future avenues in your field, and for you as a researcher to do part of that work that is basically educating people and making sure that we understand better the issues at hand?
yeah, for sure, I will continue to work on I need to work on the problem and also to identify the tool to isolate, also to prevent, to better prepare, to reduce the impact. We need to be better prepared, to put some effort on prevention, sensibilization, and education. In other words, for me, I need to continue to develop my research, to train more and more students, but also to consider and I do this more and more, especially over the last years. I take more and more time to not only to explain my research and the application of my research, but also to take time to go to public event to explain, to sensibilize, education at different kind of public kind of people. Continue to work, and also it takes time, but also to have an influence for the stakeholder, decision makers, all government, because we need to have also some leader to take action, to put also some effort to be sure that we go to the right direction. And in Canada, but also it was the case also in US, we return to the past and we have certain difficulty to continue to go to go above and also to continue to work with the continuity in terms of climate action. In other words, I need to consider to take time also to work on the stakeholders and decision makers. And last thing, combine different type of knowledge with different kind of background, not only climate scientists, but for example, people who work on health aspect, because climate change has an impact and a strong impact on both public health, but also mental health, other kind of health. People who work on the management, design storm, for example, within the urban area, could be also with social people who work also on the recovery aspect for people who has been affected by hazard, atmospheric and extreme. In other words, combine different kind of discipline to work together in the same way, in the same direction, and improve the capacity to prevent, put some intervention and also recovery aspect to finalize, to develop, to reinforce resilience aspect, because the climate change will be one of the systemic risk that will be faced in the future. We need to consider to be more and more resilient about this kind of potential climate change impact, to reduce the impact, to reduce the consequence.
Because it concerns all of us.
Exactly.
All of us. Thank you so much, Philippe, for your time and expertise that allowed us to learn stress-free about understanding climate change. To my listeners, thank you for tuning in. See you soon for the next episode. I love you all. Thank you so much for listening to our whole episode. I hope you learned a lot and had as much fun as we did. If you want notifications for new episodes, you can subscribe to my channel on YouTube or on your favorite podcast streaming platform. You can also like, comment, share with your friends and family on top of subscribing. It's a great way to support the podcast free of charge, allowing me to bring you even more subjects to learn stress-free about. You may also join my Patreon and follow me on social medias to get news and teasers for upcoming episodes. All relevant links are in the description below. I'm curious, what have you learned in this episode, or what surprised you? Leave us a comment and let's keep the conversation going. To conclude, a huge thank you to you, the listeners, and to our guests. You all make that podcast possible. See you soon for another episode of Learn Stress Free. Until then, keep learning. I'm your host, Jeff Rodrigue, signing out, wishing you the best. I love you all.